We are going to look at 4.9, which is the tension equilibrium problems number 4. It says 2 wires are used to suspend a sign that weighs 500 newtons. The 2 wires make an angle of 100 degrees between each other. If each wire is exerting an equal amount of force, how much force does each wire exert? Okay, so free body diagram first. And it says the 2 forces are equal, so we know it with respect to the box or the ceiling, however you look at it, they will be at equal angles. So we'll have 2 tensions like this, and we know there's 100 degrees between them. So if we make our components look like this, we know that this angle will be 50 degrees in both spots. Okay, so we'll call this T1 and this is T2. And since we're hanging in the air, we have FG. Alright, a couple givens. It says it weighs 500 newtons. So our weight, it's just giving us our FG. And then the only other thing we can really say here is T1 is equal to T2. Alright, so next step is we are going to set up our net force equations. So we'll start in the X. And since we know these are all in equilibrium, meaning that nothing is moving in this system, we know both net force equations are going to be equal to 0. Alright, so T1x, this x component here, is equal to this x component here. So T1x minus T2x equals 0. They're acting in opposite directions here. One's to the left, one's to the right. Alright, net force in the y. We get T1y plus T2y minus Fg equals 0. Because the y components are both going up, minus Fg. So positive, positive, negative. So what we're looking for is this full tension. We know the angle within those component triangles. So if we look at the definition of T1y, we know that's T1 cosine 50, right? Okay, so we're going to rewrite this as T1 cosine 50 degrees plus T2 cosine 50 degrees minus our Fg, and that equals 0. Okay, we know from our given that T1 is equal to T2, so we're going to swap one of these out, okay? And then if we do that, T1 cosine 50 degrees plus T1 cosine 50 degrees. I'm going to go ahead and move this to the other side of the equation, so add Fg to both sides. We get equals Fg. So if we add these two together, we get 2 times T1 cosine 50 degrees. And that equals our Fg. Okay, we're almost there. So divide by 2. And then to get T1 by itself, we divide out cosine 50. So T1 equals Fg divided by 2 cosine 50 degrees. All right, now that we have this, it's just a matter of plugging in our values. So 500 newtons, and divided by the numbers on the bottom. We have 500 to get a T1 of 388.9, so I'm going to round that up to 89 newtons. And since we know T2 is equal to T1, we know that T2 is equal to 389 newtons as well. Okay, so there is our answer.